everybody. Oops, sorry, there was probably a weird echo there on YouTube. I think I just fixed that. Okay, I think everything is set. Okay, welcome on in. Hopefully we get more people coming in. That's an issue we're having right now, is people showing up to the meetings when we're in these online classes. So, but I imagine first 5 minutes or so, we usually have more people coming in. But important stuff. Those of you who are showing up to these meetings, make sure you keep doing it, right? I worry that students that miss the videos are just not going to be able to pass the course because there's so much information coming out, and we move quickly. So things you need to know, or just things you need to know and that I need to know. So I had one student who was having difficulty getting their license from the bookstore. I talked to my department head, and they are trying to assist that student. That student had some special circumstances, but if anyone else in the class is having trouble getting the license from the bookstore, please get a hold of me immediately. This class moves so fast that every day that you're not progressing works against you, and it decreases that chance of a successful finish. So if you're someone who tried to get the license from the bookstore, because remember, it's free right now, you have options. You can go there in person and pick it up. You can call them. You can email them. I've had many students say that all of those ways were successful, but I have at least one student who had some difficulty with that. But I just don't want any days getting wasted, because this is already a pretty big challenge, this course. So please talk to me after class if you're in that situation where you tried and were not able to get that license, because we don't want that to be the reason that you don't succeed in this class, right? We want to get those hurdles, those speed bumps out of the way so that you can move forward with stuff, all right? So stick around after class and let me know, or throw it in chat or something, and then it'll remind me to talk to you after class or something like that, individually. Okay, so was the other thing? Oh, the other thing, so your survey questions were due yesterday, which means today I'm making the survey. I haven't had a chance yet because I have these breaks in between my classes, but I've had office hours and I was helping students and different things, so I was not able to get that survey created. It is the #1 thing I'm going to do after class today. So after class, I'll shut down the stream. I'll talk to any students who need to talk to me, helping you with your license or questions on the homework or whatever it is that you need. I'll help you with all that kind of stuff. So if you have any kind of questions or concerns about this course, whether it be the license for through the bookstore, whether it be, stuff from chapter 1, or you don't really understand how the class works, any of that stuff, stay after class, talk to me. I will talk to everyone that needs my help. Once I have helped everyone that needs my help, then I am immediately going to create the survey that you all need to take, like, as soon as possible, right? We just don't have the time to be leisurely with this stuff in this class. So I will get the survey out. I don't have it fully completed yet, because since I haven't made the survey, I don't have the link, so it's not published, but it's going to show up right here at the end of chapter 2, right? I need to go in and edit this and make it all right, and you're going to have a link in here. So I want to explain this because I think I finally figured out a workaround how I can give points. When I first started this, we had really good participation in the survey, but it sort of was declining each time until the class that I have I have 3 stats classes this semester, an 18-week, a 15-week, and a 4-week. My 15-week class basically didn't take the survey. So I think the attitude was, well, I'm not getting points for it, so I'm not going to do it, even though it made everyone's project harder because people didn't participate. So I think I finally figured out a workaround to give you points for taking the survey. So here's what I want to tell you. The survey's anonymous. So please be honest. Put what you want to put. You don't have to fear that there's going to be any kind of reprisal. No one's going to know who you are. No one's going to be able to track down that you're an individual who said this. So, I haven't read the questions yet, but people, sometimes people ask about gender or, different stuff that people want to talk about. You don't have, it's an anonymous survey. So you don't have to be afraid that you're somehow going to get some kind of, whatever, any kind of negative results from this because it's all kept confidential. But I have to have a way of giving you points for this because otherwise certain classes, every class has a different personality. But every class has a different personality, and sometimes the personality is to not do anything that you aren't getting points for, even though it is absolutely necessary in order to complete the course. So what you're going to do when you take the survey, when you get to the end of the survey and you're either on the last problems, I'm not going to be too picky about this. If you're on the like there may be like, I don't know, I haven't looked, but let's just say there's 100 problems. Sometimes there's 70, sometimes there's 130. Let's just say there's 100 problems on the survey. Now that might scare you. Go 100 problems, that's going to take all afternoon. Now it'll take you like 10 minutes, okay? At the end of taking the survey, just take a screenshot of what you're doing. So either where it says you have completed the survey, take a screenshot, or if you're down at like the 100 question or whatever, take a screenshot. If you don't know how to take a screenshot, just Google it, whatever operating your system you're on, screenshot MacBook Pro or screenshot Windows or whatever, and it's going to tell you how to take a screenshot. Then you're going to upload your screenshot in here to where you take the survey. So I'm going to have instructions for taking the survey in here. There'll be a link to my StatCrunch and all that kind of stuff. You'll go in there. There's a link. You'll take the survey, and then you're going to take a screenshot, and you're going to come back and post it here. I can't give credit without a screenshot, so don't forget to do it. Don't forget to take the screenshot because I can't have what happened in my 15-week class where 50% of the class takes the survey. It makes all of your projects a lot harder. The results don't come out as good. We need full participation in this. So I'm going to set a link or a date, and it's going to be soon, where you have to have that. We need everyone with that survey completed. Once the survey's completed, then I can share the results with all of you, and you can start doing your analysis. Again, you're not going to be able to track down students. It doesn't have your name in there, where it doesn't say like, here's the name of the student, and here's what gender they claim, and here's their orientations, and whatever questions are being asked. It's not going to trace back to you, okay? So please try to be honest as you feel comfortable being in the survey, knowing that it's an anonymous survey. And then you're going to post the screenshot. Posting the screenshot is what you get credit for. So you if you email me and say, oh, I forgot to take a screenshot, I'm going to say, can you take the survey again and then take a screenshot? Because I'm only giving points for the screenshots because otherwise, like I say, otherwise I'm going to have half the participation, or sometimes I get half the participation that is necessary. So just be aware this at the end of chapter 2 will become live probably a couple hours. It's going to take me at least an hour to set up that survey and possibly like more depending on how many questions we got from everybody. That's if everybody submitted 5 questions, that could potentially be, possibly 200 questions, but I doubt that we're going to get to 200 questions. So I'll create that survey. I'll push it out. Please take it as soon as possible. It's literally going to take you like 10 minutes. You post your screenshot of taking it. Easy 10 points for your project, right? Your project, if I recall, is out of 200 points, but each of these little assignments you do along the way is 10 points. So it's something like 40% of the project comes from these things along the way, and that really helps buffer, because usually I'm pretty generous with the points on these little parts here because you've just learned the material. If you've just learned about correlation, I'm not going to like tear your work apart because you just learned it. But then in the final product, your final video, I'm a little bit more, little bit harsher with the grading. So where I really expect it to be good. Your graph should all have good labels. They should be set up using the proper stuff, like the proper good practices and stuff. So get these points when you can. That's an easy 10 points. It's going to help your project grade. So make sure you get in there and do that. Don't take it late. We really can't have people doing stuff at last minute. And it doesn't get, your professors are not real sympathetic when you're trying to turn in something at the last minute and then it doesn't go well. Like, it's not like we go, oh, you really tried. It's like, oh, you tried to do it the last possible minute. So just try to do it reasonably early, as soon as you can. Get in there and take the survey. The sooner we have hit that peak number, the sooner I can release the results, the sooner you can all start actually organizing your stuff and getting ready for that project. So less stressful. The more time you have to work on it, the less stressful it needs to be, right? So that will be released today, and I'll probably even send out an announcement when I do to just remind you, oh, can you pop in now and take the survey when you get a chance, and then we'll move forward with stuff. Our discussion today, we're going to finish up Chapter 2 and then get into some important discussions about Chapter 3. I know we're moving fast, but that's the nature of a 4-week course, a 4-unit, 4-week course. We're doing a unit a week. That's what we normally would do in a month. So we're moving quickly. Okay, so that's where we're going. If anyone has a question already, feel free to throw it into chat, either Zoom chat or YouTube chat, and I'm happy to answer your question for you and see what you need. Otherwise, I'm going to move ahead. Okay, so we have this idea, graphical misrepresentations of data. So one thing you hopefully have been looking at is, you're starting to look at, various things that are important to taking a survey, giving a survey, and then representing things. So we have visuals that we can use for communicating our statistics. Okay, so I think I talked about this last time. The idea when you're doing statistics is it's like you're a lawyer in a courtroom. You have a narrative that you're trying to build, right? You're trying to build a narrative that says, the huge number, like the beef industry and the huge number of cows supported by the beef industry and all the burgers and steaks that people are eating are actually contributing to climate change. So that is a big claim, right? Well, if you expect people to take action and do something about it, you got to convince people. And although, unfortunately, we live in a world where even facts themselves are not enough to convince people, many people, there's still people out there who can be convinced with facts and logic and reason. There's still people that are, sort of follow science and respect facts and stuff like that. So what you want to do is make a case, right? So that's what we're doing. So just imaginary, it's, a real world situation, but we're not actually studying it. Say, okay, it would appear that the large number of cows that are used in the beef industry are contributing to climate change. Well, what you would do then is you'd gather a bunch of statistics about cows and CO2 emissions and all sorts of different things, and you would have graphs, and you could show how these things were going up at the same time and all sorts of stuff. You want to convince people of stuff. Well, you have to do a good job if you're going to convince people. You have to have good visuals, good representations. The number one thing that I look for when someone shows me a visual, and this is usually a pretty good indicator as to how well that student's work is going to look, is it fully labeled? Is it properly labeled? Your goal should be that when you give someone a graph, they don't have to ask you any questions. They look at it and they say, oh, I know what this is. This is a graph of shoe size versus height in male students at Ventura College, right? Now, how would they know that, all that information? Well, your title is probably something like shoe sizes versus height of male Ventura College students. And then your x-axis should be labeled with units. Shoe size in U.S. sizes, right? Because around the world, they have different shoe sizes. And then your y-axis is labeled heights in inches or whatever. So you want to include a label and a unit. Whatever unit you're using, right? Include it. Because otherwise it's confusing. If your x-axis just says time, and then there's a bunch of numbers, well, is your time in seconds, minutes, hours, days, weeks, months, years, decades, millennia? I don't know. I don't know because you didn't put a unit in there, and it's not clear to me. So then I would have to ask you the question, what are the units of time? And then you lose. And I don't mean you lose like with me. I mean, this is kind of the way you can think about it when you're constructing your graph, is go, okay, if someone looks at this, is there anything they won't understand? Is there anything that I would need to explain to them? And if the answer is yes, then you should include that in a label or a title or, a note that you put in there or something like that. But a visual should be fully representational. You shouldn't have to explain anything. Because, like, how many times has someone ever said something to you and you're like, give me your scratch work, I'm going to check your math. That never happens. No one ever wants to look at anybody else's math, right? Ever. So really all people look at are conclusions and pictures. People, we still just like to look at pictures, right? Just like when we're little kids and we like with the books with the pictures in them. Adults are the same way. Many adults are the same way. We just want to look at the graph. We don't want to like read words or anything like that. It's actually an issue that we're seeing in education, is that people don't like to read very much stuff. But pictures they'll look at, right? So you want to be able to show a picture and it fully sums things up. So that comes up in this chapter 2, about organizing our data and what we're going to do about it. We looked at histograms last time, and you've kind of seen in these lessons some different representations. So I want to reiterate, remember, this class moves so fast, I can only cover like a fraction of the things that you need for this class. So what I try to do is the stuff that's mechanical and obvious and the details, I leave to the lessons. But the big picture connections, I try to go over that in class because sometimes it's hard for it to come through in those lessons. So the concepts, which is really all that matters. These days, if you're doing statistics, you have something like StatCrunch actually crunching the numbers for you. That's why it's called StatCrunch. You're important because you can interpret those statistics. You can read a visual for statistics. You can make a visual for statistics, right? Because even if we're using StatCrunch to make our visuals for us, we have to tell it what settings we want in there. We have to know the labels and the units, and we can pick the bin size and all these different things. We have to modify it till it's really good, till it looks right. The computers still can't do that on their own. They can make a graph with some default values, but are they going to make the best looking graph? Probably not, right? That's up to you to get in there and mess around a little bit. That's why I've said, and I'll say again, when you make a histogram, probably shouldn't just make one. Get in there and fool around with those settings a little bit and make 10. Making 10 histograms will take you about a minute, okay? And then you'll have 10 histograms, and you can choose the best one, and it's probably going to look better than the one that's based on the default values, right? And then the one that you like, then go in and put the title in there and the X and Y labels and units and all that kind of stuff and make it really good, and then just save it into a file, and then you'll have it on your computer when you go to make your video at the end of the semester, and everything will be largely ready to go. Okay, so there's all these visuals that you've been looking at, but then we get into graphical misrepresentations of data, and these can happen for two reasons, right? And it has to do with just the world that we live in, unfortunately, is everyone is trying to trick someone else, right? Everyone wants money and power, and so everyone's trying to trick someone else into, they're trying to trick you into buy something. They're trying to trick you into voting a certain way. They're trying to trick you into agreeing with them, like whatever it is, right? And people are willing very often to be unethical in that pursuit because if they can get you to buy the car, then it doesn't really matter if they lied to you. They just got the sale, right? If they can get your vote and get elected, it doesn't really matter if what they said was true or not. They're now in power, right? So sometimes people misrepresent data accidentally because they're just bad at statistics or don't know statistics, and this actually happens regularly. We're going to see some examples of this. And sometimes people misrepresent data intentionally because if I can show you a graph that triggers you emotionally, then I'm kind of in control, right? I can manipulate that fear, that anger in you, and then I can convince you that that feeling should lead you to agree with me, with my point of view. This is done all over the place. This is done, just turn on the news and you'll see it, right? Especially if we're nearing an election cycle. Things just go nutty with statistics that sometimes are done well, sometimes are done poorly. Oftentimes you'll hear politicians and people on the news and stuff cite statistics and then just do it so badly. Like they just completely mess up. They'll say, here's what somebody figured out. Here's the conclusion. And the conclusion might not be a reasonable conclusion at all to draw from the survey that was done. You want to be able to tell the difference and look at a graph and go, I see this graph was meant to get me upset, but actually, if I look at it, it's not as bad as this graph is trying to make me think it is. Okay, so hopefully you're all interested in being ethical in your statistics and not trying to sway people, but it is out there and we need to be aware of it. So I'll show you some real world examples of that kind of stuff when we get into that in just a second. And then we'll have examples from this book, which are also helpful. So there's a section in here, graphs that enlighten and graphs that deceive. That's basically the same type of idea as what we're talking about. Let me get to the right. Get it in the right spot here. Oops. I don't know why. Sometimes this thing fits better on the page than others. There we go. That's not bad. Okay, so scatter plots. You should have a scatter plot in your final presentation. Scatter plot is the reason that I asked you in your questions to make sure you have 2 quantitative questions. That way you can make a scatter plot and do correlations and regressions. So you should have something like this in your final project. In fact, yours is even going to be fancier than this because it's going to have a linear regression in it. We'll talk about that later in the semester. StatCrunch is going to make it for you. You just have to tell StatCrunch, okay, here's how I want you to set up my scatter plot, and then it's going to make the scatter plot for you. So it's pretty straightforward. And like I say, if you have questions along the way, you can ask me when we get there. But see how they have this here? Look what they have. They have a title, weight and pulse rates in males. So right in there I know, okay, what did they do? They took a bunch of guys. They figured out their weight and their pulse rates. Okay. Okay, so the x-axis, that's the ones where that's the weights. Is that in pounds? No, it's in kilograms. How do I know? Because they put the unit right here. Very helpful, right? No, we're not going to make any mistake and be very American-centric where we're still sort of using imperial measurement for some unknown reason instead of the rest of the world that's using metric system. We go, oh, that's in kilograms. Okay, good. Now I know. And then over here, pulse rate in beats per minute. It's probably obvious that pulse rate is almost always in beats per minute, but just put it anyways. Then there's absolutely no confusion. And what do we have here? We have a scatter plot, fully labeled. Title, x-axis is labeled, y-axis is labeled, and I can see what's going on. Okay, so that's an example of a good graph. That's a good one. Okay, we're going to see a few that are good and then a few that are bad. Scatter plots are helpful here. So remember, we talked about the penny example last time. And we talked about that gap that was in the frequency table. Well, here we see groupings. This gap is represented by the gap right here. So what do I see? Oh, the pennies that are from certain weights, those existed from like 1983 and after. The heavier pennies, those are from 1983 and below. So see how we have it's another visualization of the fact that there's a difference between these pennies. If you're just looking at a big list of pennies, hard to tell the difference. Now, they didn't put the unit here, but guess what? They put it in the title. So it's still there. I still know, oh, they used grams, the weights in grams of pennies. You don't have to put it in both places, but it should be in one. Because otherwise I wonder, did they use ounces? I don't know. Penny's pretty light. I don't know. But you just answer my question if you put the unit in there somewhere that we can look at, okay? Dot plot. Dot plots are helpful. You don't see a lot of dot plots. They can be helpful because one thing about a dot plot is you can get back the original data. Sometimes that's helpful, sometimes not, but you can create a dot plot here. Basically, what you do is for each data value, you put a dot above that number. And so see this where it's really high, that means, let's just say that's 95. That means there was a lot of 95s in our data. And there was only one 100, and there was 3 80s, right? So you're just creating, again, it's a visual representation. And you'll gain a better appreciation for these graphs that we're looking at today after we do the next couple chapters, after you understand measures of center, after you understand the measures of spread, that is the shape of the data, you're going to start recognizing those things in the graphs that you create, and you're going to, oh, there's the center. Oh, that's how much the spread out it is. and you're gonna have a better appreciation, like art appreciation, right? You go through a museum and you're kind of bored. Then you take a semester of art appreciation and you learn all about art, and then you go back and you're like, oh, I see what he did in this picture, and I see what she was doing with this sculpture, and like you see a lot more things. That's gonna happen in the next few chapters. So, remember these. Stem and leaf plots, these happen. I almost never see people actually use these. The way it works is this over here is the beginnings of your number, and then these are the ones digits. So in other words, this 5, and then we have a line with a 0, 6. That represents that in our data there was a 50 and a 56. Nothing in the 60s. And then for 70, there was a 70, 72, 73, 74, 75, and then look, a bunch of 76s. Where we have the 6s in a row here, a couple 67s, and then a 68, right? What about when we get up here 11? That means 111, 115, 115, 118. So you're just putting the ones digit on one side of the lines because it kind of helps you see the shape. We can see where the most of our data fell. It fell in the 80s and 90s, right? That's, again, it's just a visual way of representing that data, but it's not one that's used terribly often. Okay. Bar graphs. People have a tendency to mix up a bar graph and a histogram, because you look at that and you go, wait, isn't that what we learned about last time, a histogram? No. So there's a couple differences here. One, generally a bar graph is going to represent categorical or qualitative data. A histogram represents numerical data. So that's why your bars on a histogram touch each other, because it's numerical. You have something that's increasing, right? If you have ages, then you move to the right as you increase in age. With categorical data, that usually doesn't make sense to have things in a range like that. That's why they're separate. Okay, and here we have a multiple bar graph because there's 2 bars. They're showing men and women at the same time. So you've got men, and then, oops, go up a little bit more. Males are blue, females are pink. And then we can look at 2 things at the same time. But you can just have a single bar graph where it would be just the blue values or just the pink values, something like that, right? But notice how they're separate. And in this case, it's by decades. So you could still kind of argue there's a continuum. But imagine if this was eye color. Blue, brown, green, right? It is not necessarily a best order to put them in. Okay. And StatCrunch will make all these charts for you. So all you have to do, if you ever get confused about using StatCrunch, first of all, your homework has a lot of clues. I should show you that in a minute just to make sure everyone knows about that, because I'm still getting students in my 15-week class that haven't really discovered all the tools in the homework. So I'll show you that in just a minute. But what was I going to say? But if you go into StatCrunch, it'll make all this for you. If you ever get confused on StatCrunch, just go into YouTube and write StatCrunch and then whatever it is you're trying to figure out. StatCrunch bar chart or StatCrunch histogram or whatever it is you're trying to do. And someone's going to have like a 3-minute video that shows you exactly what to push in order to get your graph. And then, of course, you just have to make little adjustments to the parameters to make it look good. So let me go back to what I was saying because I want to make sure to show you this. Let's say we go into, let's go to something where I know it's a little more complicated. Let's go to here. I'm going to go to the assessment. So I'm opening up the homework. Hopefully nearly all of you have done this by this point. Let me just guess the question 7 will work. There we go. Okay, so notice what I see here at the bottom of this problem. We've got a few things. Actually, I can show you a whole bunch of stuff here, which is great. Okay, so you have a bunch of data in a problem. If you click this blue box over here that says data table, a couple things happen. One, it gives you the data. You go, okay, that's kind of nice, but that's not terribly helpful. But look what happens if you go, oh, wait a minute. It's not doing it. Oh, here they have it in 2 places. Sometimes you click this to get to StatCrunch. Sometimes it's this. So see this little, they mix it up a little once in a while. See this little box right over here? If I click that, it says, do you want to open this data in StatCrunch? You go, sure. And it's opened on a different screen, but if I move it over, we now have our data. It just opened this data for me, the data from this problem, right? It's this data in this problem. It opened that for me in StatCrunch. So now I can use the StatCrunch tools on the data for that particular problem. So once you learn how to get StatCrunch to calculate the stuff for you, you just have to, you have the data set here, and then you have StatCrunch do the crunching of the stats, and then you interpret your answer, right? And it sounds like, well, StatCrunch is doing everything. Believe me, like, there's still, most of the real thinking is in understanding how to use StatCrunch and how to interpret your answers and ask yourself, is this the answer that StatCrunch wants, or is it this one over here? Okay. Okay. The other thing you can do, see down here, there's a couple of things. Not every problem has this, but there's a few. Done. It says, help me solve this. That's where it walks you through the problem. You probably don't usually want to use that one, but you can if you're really stuck. But then it says, view an example, and you can look at a similar example where they walk you through it, part A. They're like telling you what to do. So sometimes that's helpful, and you can continue through. It gets you through the different parts. Now it's on part B, and you keep going till you finish, and then you'll come back and try to do that for the problem that you're working on. Okay. Another thing, get more help. If I click this, it says StatCrunch, and if I open that, it'll just open a blank StatCrunch window, which can be helpful. But usually if you're in the homework, you're probably wanting to open the data set in StatCrunch, which I told you how to do. But look at this tech help. If I click that, it gives us some information on how to use StatCrunch. So it's got the TI-8384, which we're not using because everyone's we're not on campus. If we were on campus, you all would have checked out a free TI-8384 till the end of the semester, and we would be doing stats in class. We don't have that, but we don't need it because you're actually on a computer using StatCrunch, which is better. It's better than the TI-84. But look, it gives you instructions, step-by-step instructions on doing this, what you need for this type of problem in StatCrunch. So it tells you, select graph and highlight scatter plot. Do this, do that, right? So if you're ever confused, those are two things or a couple things that are going to help you move through the problem and be able to complete it. Okay, so you can always just be aware. Sometimes I know, like, all of us have sort of been trained, even, you know, especially those of you who grew up with the internet, but those of us who knew life before there was an internet, even us have been trained that when we look at screens, we ignore certain things because we're used to ads being there or unimportant information. We just ignore it. Bottoms are one that we ignore, bottoms of screens, and then the right sides of screens, because that's often where ads end up, right? But just be aware, oh, here at the bottom, don't miss this, because this is all helpful stuff for you to be able to complete that problem that you're working on. Okay? So I just wanted to show you that because I know some students in my other class have sort of forgotten or never really quite figured out that this help is available in there. Okay? Yeah, let's leave that page. Okay, where was I? We were looking at graphs. Where's my, okay, so we've got that. A Pareto chart. Now it sounds like, oh, a Pareto chart's like a whole different thing. No, oh, here, I got to get this back in the right spot. Okay, so a Pareto chart is just a fancy bar chart. See how this one's kind of nice and organized? A Pareto chart is just a bar chart, and technically these should be separated. I don't know why they did this where there's no gap in there. But your bar chart should have little gaps in them. But see how they did them in order from greatest to least? That kind of makes sense because then they're automatically ordered, and you immediately know, oh, family partner is what contributes the most happiness to these people, and sports is the least. Okay, so you sort of already have them in order. It's like taking this, but just being a little more organized. In fact, this one is pretty well organized because it goes from least to greatest. So actually, it goes from chronologically, which also happens to be least to greatest. But the Pareto chart is just nice. You take that extra step to either make your bars be increasing or decreasing. It's just a little extra level of organization that's going to make your visuals pop. It's going to make your visuals communicate better, right? The whole point of your visuals is to communicate what you're trying to convince people of. And the better chart you come up with, the more people you're going to convince, really, is the bottom line. Pie charts, not great. Pie charts are kind of people's go-to, but they have a number of drawbacks, right? In fact, I think that you can even see this. This is an old version of Triola. It's the most widely used statistics textbook in the country. It's not the textbook we're using for this course. It's just another one I use for visuals. In this book, they say, never use pie charts because they waste ink on components that are not data and they lack an appropriate scale. So the #1 selling statistics book in the nation actually says never use these, and yet people go to these immediately. There's good reason not to. One is, yes, they use ink, although we're largely becoming more and more paperless society, so we're not actually printing things a lot of the time. But the other problem is it's really hard to tell scale. Like, look at the red and the green. I can tell pretty easily that the red is bigger than the green. But is the red 2 times the size of the green? Is it 2.5? Is it 3 times? How much bigger is the blue than the red? 6 times? 5 times? 8 times? It's really hard to know. If all of these are a bar, then you pretty easily can go, that bar is 3 times as tall as that bar. That bar is 1.5 times as tall as that bar. Whereas here it's like, you know, how many yellow pieces would it take to fill the blue? I don't know, 20 maybe? Who knows, right? So there isn't really a good scale. Sure, they look cool. They look kind of neat, but that's about it, right? And you in statistics, it's like a lot of things. You want your stuff to look nice, but you really want form. You want like the results are more important than how it looks, right? It's like a piece of furniture. You get this really nice piece of furniture and you like sitting on it. Oh, this couch is great. I like sitting on this couch and it's so comfortable and I can just take a nap and I can sit here and it's great. And then next thing you know, there's like 12 pillows on the couch and you're like, okay, the pillows look kind of nice, but now I can't relax on this couch, right? So with statistics, you want to make that choice of making something useful over making it look good, okay? All right. Frequency polygon, probably not going to use those in your project, but you're welcome to if you want. Those we don't really need. Okay, graphs that deceive. Okay, first thing, NonZero Axis. In fact, we'll look at some examples and then we'll go through these. But NonZero Axis is a big one. There are times where it's appropriate to not have 0 on your y-axis. But if you do, you need to make sure that you draw attention to it and make it obvious, because otherwise what you're going to do is deceive people. And that is actually a technique that people do on purpose because there's really no other reason that you would do it, right? It's like the only time you don't call out something that's kind of weird is when you're a little bit guilty of something, right? If you make a mistake and then you fix it, you just go, oh, by the way, this is like this because of this, and here's what happened, and then everyone goes, oh, okay, and then you move on, right? It's when people are trying to hide stuff, it gets a little weird. So here's what I'm gonna say. I'm gonna show you some graphs from TV that are considered bad or deceptive. I don't want this to turn political, right? But there is one particular news channel that is sort of famous for bad graphs, okay? There's entire websites devoted to breaking down how bad and deceiving the Fox News graphs are, okay? So without getting into politics, we're just going to look at examples. Can you find examples where CNBC does it wrong too? Probably, but Fox News is like infamous for this in the statistics world because they always have bad graphs. So let's take a look at a few things here. So this is a bunch here. Business Insider has a big write-up on this. Here are the tricks that Fox News uses to manipulate statistics on its graphics. That's the Business Insider article. Here's just something that doesn't even make sense. I don't think anyone was trying to be deceptive with this. I think this was hard to find, but literally an individual who didn't understand what a pie chart was, right? The pie chart is supposed to show you the percentage out of 100%. That's what a percentage is. It's literally out of 100%. Here we have a pie chart. Let's add up those numbers. That adds up to almost 200%. So you can't really get any kind of context. Now, is it a cool 3D looking pie chart with some good shading on it and everything? Yeah, it looks really good. Does it mean anything? No, it doesn't really mean anything at all. There is no argument that you can make that this was the right tool to use for this. And then even when you use the pie chart, this was used completely inappropriately. Also, your source shouldn't just be opinions. Yeah, of course they're opinions. Like who people are backing in a presidential, that's their opinion. That's who they're voting for, right? Their opinion of who they're going to vote for. So your source, you should cite a source not as opinions, but like explaining. I asked 100 VC students, and here's how I selected them. Something like that. It's silly to just say your source is opinions. Here's the one that we were getting at in the book was that zero axis. So what do you see when you see this picture? What you see is this bar is about 5 times as high as this bar. You go, man, that's huge. Taxes are going to be 5 times as much if the Bush tax cuts expire. Your taxes next year are going to be 500% what they are this year. Oh wait, now I'm looking closer and I see that's not what's going on. Look at this bar is 35%. This bar is 39.6%. This is only a few percent higher, but they make it look like it's 500% higher. Why? Because they've picked this weird scale. This is a thing you'll see this almost every single day, maybe literally every single day if you watch Fox News. You'll see a chart like this where they break one of the #1 rules of statistics is that you should include 0 on your axis, because if you did, these bars would almost be the same height. If you started at 0, this one would go to 35, this one would go to 39, and you wouldn't get that emotional reaction that they're trying to get out of you, that to shock you, to put the fear into you that your taxes are going to go up by 500%. You would go, oh yeah, they're going to go up marginally. If the Bush tax cuts expire, they're going to go up about 4%. And yeah, that's not great, but it's not going to put you in a panic that you won't be able to like afford your house and your food and stuff like that. So this is a great example of exactly why you don't do this. Plus, it's a little like, how often do you see the y-axis on the right? It's very, very rare that you see that done. To me, that suggests that they're trying to, again, hide it because they don't want you to recognize that 34 is actually at the bottom, right? So very misleading. There's lots of examples. You could just spend the rest of your day looking at examples where Fox News does this, where they show an inappropriate y-axis, and so that's where the book covers it. Right here, a non-zero axis, and says, yeah, like here's an example, right? Here's what we were just looking at. If we have the non-zero axis right here, it starts at 30. It makes it seem like the Honda Civics. What is this? Fuel consumption, vertical. It's like way more than the Camry. You're like, man, this Civic, this bar is like 6 times as tall as the Camry. But look what happens when you use an appropriate scale with a 0. You go, oh, yeah, the Honda Civic is marginally higher than the Chevy, I've never even seen that word, Aveo, which is marginally higher than the Toyota Camry. Okay, this gives you a much more realistic understanding of the comparison between these three. This one is put in there to elicit some type of emotional response in you. Maybe this one's put out by the Honda people, and they want you to think, yeah, our miles per gallon is like 5 times what the Camry is, right? So it's in Honda's best interest to make you go, man, this bar is really high. Where if you look at them in an appropriate statistical scale, you go, yeah, Honda's better, marginally better, a little bit. Okay, so that is exactly what was going on here. Oops, over here with this. This is intended to make this bar look significantly out of proportion than it is. So your graph should start from 0 whenever possible. Now, there are times when you can't because the numbers are so huge that by the time you get the whole thing on there, you can't tell that there's any difference at all. So then what are you supposed to do? You're supposed to call out the fact that let's see if I can find one. You're supposed to call out the fact that you're skipping. They didn't put one in here. but you've probably seen this before. On the rare instances where you don't, where you really can't use a zero scale because your numbers are too big, what you're supposed to do right here is you put a squiggly line. It kind of looks like a little lightning bolt, and what it does is it gets people attention, and it draws your attention to the fact that, oh, they're not using a zero scale, so I should readjust my comparison of these bars. So that's a big difference between putting a lightning bolt here, which draws your attention to show you that it's not a zero scale, versus what was done over here, where they move the axis over to the right to hide the fact that they didn't start with a zero scale, right? So, you know, this is fairly indefensible. There's not really much way that you could defend this as being an accident or something like that. The only way you could do it this poorly is to do it intentionally that poorly. Pictographs. These are popular because, people like to look at pictures. They don't really like words, but they do like pictures, right? Here's the problem with pictographs. This picture is, I think, is it double? I'm trying to remember. I think it was double that they did on this one. Yeah, it's about doubles. So from about 350 to 700 is the comparisons for these numbers. So, but this plane doesn't look like it's twice the size of this plane, does it? It looks like even bigger than that. So again, it's giving a, it's misproportioned, right? Well, why is that? Well, when you take a shape and you double the length and you double the height, that thing is now 4 times as big. So it's hard to increase pictures in a way that makes sense, because if you double the dimensions, you quadruple the area. So that's why it makes it look like this doesn't look twice as big as this. This looks massive, right? It makes this look like a little ant, and this is like, you know, something much bigger than an ant. But really it's just trying to show twice the size. That's why we use bars, because if we always use bars that are equal width, then all we have to compare is the height, and then it's pretty easy to tell, oh yeah, this bar is twice the height of this bar, right? There's no confusion, there's no misleading, there's none of that kind of stuff. Right, so always examine a graph to see whether an axis begins at some point other than 0 so that differences are exaggerated. You should always be looking for that. And basically, don't make pictographs. Right, I know you see them sometimes. They're not the best way of, sure, they have nice little pictures and people can go, oh, look at that airplane, it's a cute airplane, but it's not the best way of communicating you know, your stuff. And if you're doing something serious for research or a job or something like that, you want to do it in a professional way, right? Let's see, I think there was another one I wanted to show here, other examples of bad graphs. But yeah, all these, you can find all these where they don't use the zero. They don't use the zero axis. So look at this. Here's another one. This bar looks like it's about 1/5 of this bar, but if you look at the numbers, yeah, not so much. So this one doesn't even have an axis, a y-axis. That's fairly irresponsible. Here's one where it just doesn't make sense. Look how these, you'll see this from time to time, not just on Fox News, I see it other places. They took a legitimate Rasmussen poll. So there are certain companies out there that's their job, is to conduct polls, right? I just got one of these the other day when I was making dinner. Someone's like, we want to ask you a bunch of questions. And I was like, I'm making dinner. Can't do it. But there's places that get paid good money to conduct legitimate polls. Now, what happens is people take those legitimate polls and then they can twist around the results and say, you know, they can reference that thing. But the actual poll itself is done properly. What's the problem here? The problem here, right? So let's look at the question. Did scientists falsify research to support their own theories on global warming? For this poll, 59% said somewhat likely, 35% said very likely, and 26% said not very likely. Well, what's the problem here? Add up those numbers, you get more than 100%. So what they're doing is they're sort of picking and choosing which things to show you. This is being presented as if this is out of 100%, but it's not. This is really like, if you were somewhat likely, then you were probably also very likely, right? If you're if you're like really, really sure about something, then you're also kind of sure about it, right? You're like even more sure than that. So you want to make sure you're not giving information in a way that double counts things, because that's definitely misleading. Like I say, there's whole websites that sort of point these out. Here's one that doesn't. There are times when in the appropriate setting, you can do a thing like this, but it's very rare. What's the problem with this? If you look at the y-axis, the jumps go 30, 30, 10, 30, 30, 30, 50, 10, 50, 50, 50. So your heights aren't even evenly spread out. You're just choosing based on how you want the graph to look. Based on certain times, you're changing that y-axis. That doesn't make any sense for, there's extremely rare cases where this would make sense. It's not when you're trying to disseminate news to a large number of people. This is like and even then, when you're doing high-end statistics, you almost never would do it like this, right? Probably never. I bet you most people have never done it like this. So that's a very irresponsible way of showing things, where you just play around with the y-axis and change the number so that sometimes the jump is 10, sometimes it's 50. Don't do that, okay? All right. Okay, I think that's it for the ones I wanted to show you, and that kind of wraps up that graph discussion. What do we got? About 20 minutes? Okay, let's see, where are we? Then let's get into doing some statistics. Oh, cookies. Let's see, why is that so big? Okay, so one thing you want to recognize, here's some data, right? So here's some data on the number of chocolate chips in different brands. So you got Chips Ahoy Regular, Chips Ahoy Chewy, Chips Ahoy Reduced Fat, Keebler, Hannaford. So which one has the most chips? Well, it looks like maybe Hannaford has the fewest. It's kind of hard to tell. Does Chips Ahoy have more than regular? I'm not sure. And then what about the reduced fat? My point is, it's really hard to make any kind of comparisons when we're just looking at lists of data values, right? You can go, yeah, Hannaford, they apparently they don't like chocolate in their chips. But for the rest of these, kind of hard to tell. Is Keebler higher than Chips Ahoy? Who knows? So what we need to do is develop a series of tools to do what we call descriptive statistics. So that's what we'll be doing for the next few weeks. And then I guess we only have a few weeks left, but in the next week or 10 days, we'll be doing descriptive statistics. And by the end of the course, you're getting into what is called inferential statistics, where you're developing much stronger tools for your toolbox. But first, we just need to be able to describe things so that we can answer questions like, if you don't like very many chocolate chips in your cookie, which one should you buy? If you really just want the most chocolate you can get in your chocolate chip cookie, which one should you buy, right? We can do that, although that's very hard to do from just looking at these lists of data. All right, so in doing that, we will, here's comparison of dot plots. Remember we talked about dot plots a few minutes ago? Well, by doing a few of them and putting them together, we can start to go, ooh, it looks like Keebler maybe has the most chocolate chips, and you can start to gain information that we're going to learn about in this class. So you'll see this. Sometimes putting multiple graphs right next to each other is a really great way of comparing them. Like right here, this is really comparing well. Like right from here, I can already tell you, not with specifics, because we haven't crunched any numbers yet, but I can tell you, oh, you don't like chocolate? Go eat Hannaford. Oh, you love chocolate? Go eat Keebler. You don't want something that's too chocolatey? Go have some Chips Ahoy. Okay? So you can get that just from this comparison of these dot plots right here. All right, so we get to our first major concept, which is measures of center. All right, so we have two big ideas that every single time you approach a question, a statistical question, you want to investigate. One, what is the center? Two, what is the spread? What is the shape of the data? Okay, so we're not going to get to the shape of the data today, but we can talk about measure of center. So how do I pin down where the center of my data is? And the answer is there's no one perfect way to do it. We have like 5 different tools for talking about the center, but almost always you're going to fall back on one of 2 ways to doing it. One you're already familiar with, and one you may be familiar with, some of you. But some of you you're definitely familiar with one. So a measure of center is a value at the center or middle of a data set. But how do I know what the middle is? And can we make arguments that there's more than one way of measuring something that could be called the center? And the answer is yes. Okay, so the first is what we call the mean. It's what most of you have probably grown up in your life calling the average. In statistics, we don't use the word average because it's ambiguous. Some people, when they say average, mean the mean. Some people, when they say average, mean the median. So we don't use it in statistics because we want to always know what we're talking about. So if you say the actual word mean or median, then people know if you're talking about the mean or median. So you don't want to use the word average. Plus, it's good to know that there's more than one measure of center because a lot of times people always want to know what's the mean, what's the mean. People are always asking what's the mean. But sometimes the mean is really not a good measure. Let me give you an example. I don't get the question as much, but like 10 years ago, whenever you'd give a test, there was always 2 or 3 people that would ask, what was the average? What was the average? And what they're usually trying to figure out is, am I at least in the top half of the class? Like, the idea is that the mean splits the class, and then you can figure out if you're in the top half or bottom half. But the mean doesn't do that. That's why the mean is sometimes not the right tool to use. Because what happens with tests, when you give a test, there's always a few students in the class who didn't study at all. They didn't do any homework. They're like totally unprepared. But they showed up just hoping maybe I'll just get lucky and get 100% on the test even though they haven't prepared. So what happens is you give out a bunch of test scores, and there's always a couple at least that are like 0, 3, 5%, something like that. Well, that's going to pull the average down, or see, I even said it myself. That's going to pull the mean down a lot. So when people ask what the mean is, they're kind of thinking, does that mean I'm in the top half? But you can have 75% of the class be above the mean. And people go, wait, that's possible? Yeah. The mean is not necessarily split things half and half. It's one type of measure of center, but it's not always a great one. So what is the mean? The arithmetic mean, or we just generally say the mean, of a data set or of a set of data is the measure of center found by adding the data values and dividing the total by the number of data values. So it's what you've always thought of. You add up a bunch of things, you divide by the number of things that you added up. Okay, so this symbol right here, you want to get comfortable with. It comes up a lot in statistics. That's capital sigma. When you see that in math or statistics, it means add stuff up. So what does this capital sigma mean? It means I'm going to add all my x's together. What are my x's? The x's are the symbol we use for the data points. So when you see sigma x, that means add up all your data points. Oh, okay. So I take everything that I measured and I add all those together. So in the class where test scores, I would take all the test scores and add them up, and then I would divide by the number of test scores. That's what the mean is. So it's relatively easy to do. You know, especially if you have a computer doing it for you. Okay, what are some important properties of the mean? Sample means drawn from the same population tend to vary less than other measures of center. That can be useful. We don't quite understand what that means because we're still kind of in early days here, but that's helpful. The mean of the data set uses every data value. And you might go, well, yeah, isn't that obvious? Shouldn't you use every data value? The answer is no, because the median does not use every data value, not directly. You could make an argument that indirectly it kind of uses every one of them, but you'll see what I mean when we get there. It doesn't directly use all of them in calculations. So we can already see differences between the mean and median, which we'll talk about in a few minutes. One disadvantage of the mean is that just one extreme value, which again we're going to call outliers in this class, a really extreme value is called an outlier. So if you have a data point that's really far away from everyone else, right? I give the example in my class, my first statistics class. It's a bunch of students asked the ages. It's a bunch of people 18, 19, 20, 21. There was one person who was almost 70. That 70 was like way off by itself. That's an outlier, right? One outlier can change your mean substantially. And that's essentially what I was talking about when I was saying people want to know what the mean is for the test because they want to know if they're in the top half. But it doesn't really tell you that because there's a couple zeros, a 3, a 5, and those are outliers, and they pull the mean way down to the point where most people, maybe 75, 80% of the class, are above the mean. But they all think they're in the top half, but a bunch of them are not, right? So if you want to see where you fit on that scale, the mean is not what you should be asking. You actually should be asking about the median. But most people don't know the median, and so they don't. All right, and we haven't even talked about it yet. So the mean is very susceptible to outliers. That is the main flaw of the mean, because a lot of people look at the mean and they're like, that seems like a great measure of center. Yeah, unless you have an outlier, and then it really, really pulls that thing one direction. Okay, so you have to be careful about that. Some notation we use, like I said, capital sigma means add some stuff up. X's are what we use to represent data points, and this is pretty much true for the whole class, right? Until we're done with statistics, that's what these things always mean. Lowercase n, that's the number of things in your data set. So in the survey, if 40 people take the survey, your lowercase n is 40, okay? If you went out and you asked 12 people a question, then your n is 12. If you timed stoplights around town and you got 57 measurements of the times of the yellow lights, then your lowercase n is 57. Capital N is for a population. So remember, the population is the thing that we ultimately want to be studying. What do Ventura College students think of a tobacco ban? But we can't ask every student, so what we do is we take a sample. So that's the only difference here. Lowercase n is the size of your sample. Capital N is the size of your population. We almost never deal with capital N because we can't usually deal with everyone. We're going to end up dealing with samples. Okay? Right. Okay, the other big one, median. The median can be thought of loosely as, whoops, somehow I got off screen here. The median can be thought of loosely as the middle value in the sense that about half of the values in the data set are less than the median and half are greater than the median. So that's really what people are asking when they ask about when they're asking about the test score. They want to know if they're in the top half or bottom half, right? Because otherwise you don't really know what that mean is representing. They should be asking, what was the median score? Right? That's what they should know, because the median is literally the thing that breaks the top 50% from the bottom 50%. So the median of data set is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. That's really important when you figure this out by hand. Nobody figures any of this stuff out by hand anymore. We just use some stats software to figure it out for us, and then we use the median to do something. But you should understand how these calculations are made so that if someone made you do one of these calculations by hand, you could do it, but in reality, we don't. And go, well, why? Why do I need to know how to do it then? Because if you don't understand how to calculate a median, you don't really understand what the median is, and you'll end up using it poorly. You'll end up using it at the wrong time. So what do we do? For the median, if it's real easy if it's an odd number. See how they put them in order from least to greatest? If it's odd, you just pick the value in the middle, 23. The median data value for this set right here is 23. It's literally the value in the middle. Now, it makes sense. If we didn't order these, then it could just be any random number that's in the middle. But if we order them, then it's the middle and the number is literally the middle number. It's the one in the middle, right? So you got to always order your data first. What if there's an even number? Then what is the one in the middle? What you do then, if there's an even number, because you could argue that the third and the fourth spot are the middle. Yeah, so what you do then is you take the mean of those two. So you add those two up and divide by 2. and that gives you your median. And you can see 23.5, it splits the top half of the data from the bottom half of the data, right? Just like this one does. This splits the top half from the bottom half. Well, this one, when it's even, that splits the top half from the bottom half as well. Okay, so what people a lot of times, what they want to know when they ask about the mean, they really want to know what the median is, but they haven't had that. There's some other ones that are less important, so I don't want to spend too much time on it. The mode is just the thing that comes up most often. That's very for kind of specialized situations. Oftentimes you don't care what that value is. Mid-range, don't really need that. Some of these ideas are very simple, and you'll pick them up in the lessons, so I don't really want to spend time in class on it since we have so little in-class time. I don't want to spend time on some of these things that are more obvious. What was this? Yeah, measures of center. Remember we talked about quantitative data. You should only be using the measure of center on the when it's meaningful, right? Don't take the average of some phone numbers. The mean of some phone numbers. Don't try to find the median of jersey numbers. It doesn't make any sense, right? Those things aren't meaningful. You'll have some homework problems where you calculate the mean from a frequency distribution, like is described here, but you have really good videos on how to do it, and then you have that StatCrunch information to figure out how to do it in StatCrunch. So just follow along, and if you have trouble, come talk to me in office hours and I'll help you through it. I've had a couple students who got confused on that, so don't feel bad if it's confusing to you. Don't be like, oh, he said I should have been able to get this. Most students get it. But by all means, if you're confused by it, you should come talk to me in office hours, right? Okay, we have a question here. Let's see. In side-by-side bar graphs, should the bars still not touch? In the homework, they are shown touching. Your bar chart, here's one of the hard things about statistics is it's really hard to have hard and fast rules because you can almost always find a way where you can justify in this situation it's okay to break this rule. The general rule is that your bars in a bar chart should not be touching, but there are times when you can argue that they should, and there are some softwares that do it that way. But most of the time, if you look in textbooks, they'll say bars in a bar chart should not be touching. Now, the difference to that is when we were doing two bar charts at once where there was the genders, boy and girl at the same time. Then for each grouping, those can touch, but then see how there was a gap in between those. So if the software makes it where there's no gap, that's fine. Go with it. But just kind of be aware, if you can make there be a gap for a bar chart, you're technically supposed to do that. I hope that answered the question. So you'll do problems like that. Again, just follow along how to do it in StatCrunch, and it's going to do the number crunching for you. You just have to figure out how to get it to do that. Right. What are we at? 5 minutes. Measures of it. Yeah, we can't cover that topic in 5 minutes. So, yeah, are there any other questions? Yeah, and about the charts, I mean, if there's kind of a weird thing that StatCrunch does a graph a certain way, then I'm not going to like take points off of you for doing it that way because that's what StatCrunch did, right? So all these stats softwares have a little bit of weird quirks to them where they seem kind of a little bit strange. I guess with the couple minutes left, I don't think I talked about this last time, but I'll just let you know, those of you who might be like comfortable with computer programming, there's in the course why the letter R is so important. But if you just do a search for statistical programming language R, you'll find it, and then you can use that. And people do really high level stuff with that. That's for like getting super fancy because you can get everything exactly how you want it. I'm not suggesting that you need to do that for the project. But if you like to kind of geek out on some nerdy programming and you're going to do some work for the project, maybe you're someone who would want to do that. You certainly don't have to, but it's an option that's available to you. It's a freely available language, programming language. And if you were someone who was interested in that, statistics is, you know, if you're choosing a job that's going to keep you employed for the next 40 years, statistics is going to be around. Many of the jobs that people are now going to school for won't really be around 10, 15 years from now. But statistics is going to be around. So if you find that you like statistics, it's not a bad way to go, and the compensation isn't bad either. Most things that involve math and statistics, you're gonna get compensated decently for doing it. So just in case you're interested in any of that. Okay, so I'm gonna go ahead and close down the YouTube stream. Anyone who wants to ask me questions for any reason, you know, obviously appropriate questions, but for any reason related to the class, please hop into Zoom, and I will stick around as long as people need my help. Okay, because there just is no time to wait. Oh, also, did I go over the calendar? Thursday is Veterans Day. So we have 2 Thursdays this month we don't meet. So this class is really going to fly by. Veterans Day and Thanksgiving, we don't meet on those days. So when there's no meeting, don't be surprised. It's because of the 2 holidays that we have in the month of November. Okay? So with that said, I'm shutting down the YouTube stream. Come see me.